Okay, so chapter 2, Argon diagrams. Okay, there's two ways of showing a complex number on a two-dimensional diagram. The two-dimensional diagram is called an Argon diagram, and it's very similar to your Cartesian grid. It's got horizontal axis, which is called real axis, and it's got vertical axis, which is called imaginary axis. Each point is the real part of each point corresponds really to the x-coordinate on the Cartesian grid, and the imaginary part corresponds to the y-coordinate on the Cartesian grid. Right, so to plot a point, a complex number, you can plot it as points or as vectors. So as a point, we've got to plot in example 1 minus 4 plus I. So you go, let's say there is my scale, indicate the scale, minus 1, minus 2, minus 3, minus 4, 1I, here is Z1. 2, 3 is Z2, and 2 minus 3 is Z3. Well, complex conjugate, you can see that conjugate pairs are symmetrical about the real axis. You might want to plot the points as vectors, and if an exam question asks you to plot a point on an Argon diagram, it's really crucial to indicate the scale. So when you plot the point, you could either write the the complex number next to the point, or write it in 2 minus 3I, so indicate whereabouts you are on the axis here. I've indicated the scale, so everything is clear. Right, so this one here is 4 across because the real part is 4, 1 up. So this one here is I, and this is 1. This is our complex number Z1. But you've been asked to plot it as a vector, so draw it as a vector. So you go and join the point with the origin and draw an arrow head. Then the 3 across and 3 up, here's Z2. And then you've got to find what Z plus Z1 is. So you can actually add them together. So if you add 4 plus I and then add 3 plus 3I, you should be getting 7 plus 4I. So it's 7 across, 1, 2, 3, 4, 5, 7, and 3, 4I, 1, 2, 3, 4. So this is Z1 plus Z2. Obviously join it with the vector from the origin. And if you notice, this is confirmed by looking at it graphically with vectors. If I have Z1 and then slide Z2 across over here, you will get the sum of the two vectors. Okay, so you've got exercise 2A, I think actually there's example 3. Let's do example 3 first, and then you can do exercise 2A. So example 3, you've got a complex number Z1, it's 2 plus 5I, and then Z2 is 4 plus 2I, and we have to show Z1, Z2 and Z1 take away Z2 on an Argon diagram. So we'll show it as vectors. That's what I tend to do with complex numbers. unless there's more things going on and it would be just a bit untidy. So 2 across 5 up, so it's 1, 2, 3, 4, 5. Here's my Z1. Then you've got to do Z2, it's 4 across 2I. And then we have to find what Z1 minus Z2 is. I mean, we're going to do Z1 minus Z2 by doing 2 plus 5I minus 4 plus 2I first. That gives me 2, take away 4, which is minus 2, and then 5I minus 3I, so it's plus 3I. So it's minus 2 plus 3. So there is the Z1 minus Z2. Let's just draw the vectors Z1 and Z2 completely. Okay, and then, so this is my Z1 and Z2. Now, if I wanted to do Z1 minus Z2, so I need to attach to Z1, where so following Z1, I need to attach minus Z2. So minus Z2 is this vector, but going downhill. So for 1 down, you go 1, 2, 3, 4 across. So for, 1, 2 down, 1, 2 down, you're going to go 1, 2, 3, 4 across. 1, 2, 3, 4 across. So this is minus Z2. And you do get the overall combined vector of the two combined overall of Z1 minus Z2. Okay, so now we're going to go on to exercise 2A. Okay, in this part